parametric. Okay. All right, so I really don't know if you have ever seen parametric equations before. Parametric equations define your variables. You're used to seeing equations with x's and y's, but parametrically, x and y are defined in terms of another variable, usually t, but in trigonometry it might be theta or something like that, okay? So, an example of this is right here in number 1. X is t plus 1, and y is t squared plus 2t. So x and y are both defined in terms of some other variable called the parameter. So t is our parameter. Now, this is very often done when we consider moving objects. So if you think about an object like moving, what does this say? Like here's this object moving. This point right here, would you agree, is an x and a y? But parametrically, x would be, let's say t is 1 second. T is 1. Then this would be the x coordinate and the y coordinate at time 1. And then at time 2, there would be a different x and y. And at time 3, and so on. So very often, that third variable, the parameter, is time. It doesn't have to be, but it often is. All right, so let's see what we're doing with this. Find all the points determined by t equals -2, -1, 0, 1, and 2. Okay. Find all the points determined by these 5 t values. So there's going to be 5 points, and the first t value is -2. So what's my point? What's my x and y if t is -2? -1,
0,
0. We're just putting -2 in for t. So then we want to put in -1. So now our point is, if we let t be -1, our point is 0.
Oh, it's negative.
-1.
Thank you. I feel like I'm stretching you a little bit here. Shouldn't be. This is so t is 0. That point would be if t is 0.
1,
0,
2, and 0.
1 and 0.
Yeah.
And if t is 1,
2,
2 and 3. And finally, if t is 2, 3 and 8. You okay with that? That's easy. So to find our actual points that we're going to plot, this would be really hard to graph. Your calculator can do it. But it would be really hard for us to graph because there are 3 variables floating around in there. But if we consider individual points by specific t values generated by those t values, we can plot these points now. We have x's and y's, we can graph it. We will shortly. B, eliminate the parameter. In other words, find the algebraic relationship between x and y. So, can you somehow combine these equations so there's no more t? Yes, you say yes. How? Now you're changing.
Maybe set both of them equal to.
Tess has got it. What, Tess? Talk loud. You always talk so soft. I'm 63.
X minus 1 equals t and then plug in.
Exactly. She says, let's just use our good old substitution. We can solve that top one and say x minus 1 equals t. And and then take that x minus 1 and plug it in for the t's here. You see what she's doing? So you're going to have an equation that says y equals x minus 1 squared plus 2 x minus 1. Or y equals x squared minus 2x plus 1 plus 2x minus 2. Or y equals x squared minus 1. Is that all that's left? Did I do that right?
Yeah. Do you need to factor it again?
No.
Or?
No.
Okay.
The only reason you would ever factor in this situation is if you somehow could cancel. But there's no cancel. What shape is this?
Parabola.
Okay, tell me about it.
Right.
Whoa!
So one down.
One down. If you can see your BFF, whatever's tacked on the end of that moves you up and down. So this is the shape that we should have, right? Let's come back and look at our ordered pairs. And I know I haven't plotted anything, but if I were to plot just the 5 that I've got, -1, 0, 0, -1, 1, 0, 2, 3, and 3, 8, does it look like I might have the right shape here?
Yeah.
How cool is that? All right, so again, vocabulary wise, we eliminated the parameter. We got rid of the T. Graph by hand, already done. Did it. Graph on the calculator in parametric mode. All right. You know you have a mode button on your calculator, right here where I'm pointing with my finger right here. If you go down, now I don't know, for me it's the 4th row, but in my 4th row, I see FUNC, PAR, POL, and SEQ. All right? Now, normal graphing is in function mode. So all the graphing we have done so far has had Y's and X's. We graphed in function mode. Now we're going to graph in parametric mode. So we're going to click over to, not there. We're going to go down, click over to parametric, PAR. All right. And now when you hit Y equals, what happens? It brings up an X and a Y, right? It says, you have an X sub 1T or something, and then Y sub 1T. So what that's telling you is, he wants you to describe X in terms of T. So X is T plus 1. Remember your variable button right here? Do you remember when you looked at it and you said, oh, it's got an X, but it also has a T? There it is, that's your variable button. Anytime you need a variable, it will come out of that button. So X equals T plus 1, and then Y equals T squared plus 2T. Now, I have no idea what my window is set at. I'm just gonna hit graph. No, not good. So I'm gonna zoom, standard, see if that helps. Nope, I'm gonna go back to my window. When I set my window up every day until today, I put in limits, or highs and lows for X and Y, right? Now I gotta do it for T, okay? So let's just let T be -10 to 10. T step, just leave it alone. I don't know how it's set. Let's see if you get a picture. We'll talk about what that does later. And let's hit graph now. Now do you get the whole parabola? I heard a couple of you say I only got half the parabola, and that's because your T started at 0 probably, and you want negative T's too to get the whole picture. So I just let T be -10 to 10, I let X be -10 to 10, and Y be -10 to 10. And I got my parabola. Does it look like we thought it would look?
Yeah.
Perfect.
Wait, when it
I would draw a picture of what I saw.
Yeah.
But yeah. All right, now we're gonna repeat. We're gonna do exactly the same thing. We're gonna do exactly the same thing for x equals t squared plus 2t and y equals t plus 1. All right? So as quickly as possible, would you come up with your 5 ordered pairs? We're using the same t values, so -2, -1, 0, 1, and 2.
0, 1.
So it'll be 0, -1.
-1, 0.
0, 1.
3, 2, 8, 3.
Wait, I erased them. Are those just the backwards of what we got before?
Yeah.
Does that make sense?
Yeah.
Yeah, because what did I do? I switched the x and the y. So that makes sense, okay. Step 2, eliminate the parameter. All right, so this time, I'm gonna say y minus 1 equals t. So x equals y minus 1 squared plus 2y minus 1. Did you get x equals y squared minus 1? Which makes sense, right? Because we just talked about it. Switch everything. What is that picture? It's a sideways parabola, right? And if x is 0, y is 1. Negative. This is 1. Y is 0. Y is 0. Now, we talked about how we might graph that on our calculator yesterday in function mode. We said we'd have to do what? If we wanted to graph in function mode yesterday, we would have to create the implicit functions. Remember? Yeah, we just did that. Yesterday, the day before, someday soon. Recently, we did that. So we're gonna create the implicit functions. But we don't have to do that in parametric mode. Your calculator will graph it just fine. Put in your new equations.
What equation?
Put in your parametric equations. This is what you're putting in. Your parametric mode, so you're graphing your parametric equations. Did it graph what we thought it would graph? Yes. So, in function mode, your calculator has huge limitations. It only graphs things that are functions. But as soon as you switch out of that mode, you can graph any shape. So eventually we'll get to polar mode. We'll be graphing all kinds of like spirals and all kinds of crazy things. Because your calculator doesn't care if it's a function unless you're in function mode. All right, you okay with that? Parametric, you good? Think you got that kind of figured out? You remember your calculator's in parametric mode now until you switch it out of that. So if you try to graph something normal, it ain't gonna work. You have to put it back into parametric function mode. All right, question 3. Consider the absolute value function. Okay, it's one of our BFFs. The shape is a V. Is its inverse a function, y or y not? Is it 1 to 1, y or y not? Now, I want you to think about what just happened with the two sets of ordered pairs we did. We did a set of ordered pairs for the first problem, then we did a set of ordered pairs for the second problem, and what happened? The x's and y's just change places. That is an inverse relationship. When two functions switch each other's ordered pairs, they like undo each other. So if in the original 2 becomes 3, then in the inverse 3 will become 2. That's what it means to be an inverse. Those ordered pairs are flopped. So I'm going to look at my absolute value function. I'm just going to plot a few points. And I actually don't have to plot very many of them. Would you agree there are at least 3 points for my absolute value? Now, that is a function, hands down. But what if I switch those ordered pairs? This one becomes 1, -1. This one becomes, or stays, 0, 0. And this one stays 1, 1. Wait a second, guys. Is that a function?
No.
No. That equation would be x equals absolute value of y. We talked about it yesterday. It's a sideways loop. Inverses switch ordered pair, or switch the order of the variables. This is not a function, clearly. Is it 1-to-1? Did we talk about that the other day? What did we say about 1-to-1? What is 1-to-1?
It needs to pass.
Uh-huh.
There's no repeating x's or y's.
Exactly. So we think about that for a second. Don't I have repeated y's right here? So if you're gonna be 1-to-1, you have to pass the horizontal line test as well as the vertical line test. The absolute value function does not pass both. Therefore, its inverse will not be a function. Because if it doesn't pass the horizontal line test, it must have repeated y's. When you do the inverse, those y's become x's, and now you got repeated x's, which are against the rules. So, 1-to-1 functions are gonna pass both tests. So the answer to this question is, the inverse is not a function, doesn't pass the vertical line test. Is it 1-to-1? No, neither one of these are 1-to-1. I'm not sure what it means, but this one's not 1-to-1 because it doesn't pass the vertical line test. This one's not 1-to-1 because it doesn't pass the horizontal line test. Now let's look at the reciprocal function. And instead of looking at ordered pairs, let's just consider the curve. What's the equation of the reciprocal function?
Y equals 1/x.
If I were to switch those variables to get the inverse, if I switch those variables, it would be x equals 1/y. Are those two really the same equation?
Yeah.
Think about it. Come on, let's get out of the fried chicken mode or whatever you ate for lunch, and let's get into math mode here. Yx equals 1, y equals 1/x, aren't those the same? So the reciprocal function is actually its own inverse. It's its own inverse. Is it 1-to-1? Does it pass the vertical line test? Does it pass the horizontal line test?
Yes.
It is 1-to-1, and it is its own inverse. Inverses are reflections across the identity line. If I were to fold my paper on the identity line, do you see how the two pieces would come together? Pieces should be falling into place for you right now. What's the test of symmetry for the identity line? Test of symmetry for identity line. Switch the X and Y. And then check to see if the same equation comes out. Isn't that what we did here? So this was actually like the test of symmetry to the identity, but inverses are reflections across the identity, so since it's symmetric, it's its own inverse. Unlike here, if I folded this one across the identity line, you see how I would get this picture? It is not its own inverse. But the inverse is a reflection across the identity. It's a new picture. This is exactly the same picture. All right, got it. We said it's 1 to 1, we're all set. All right, now we're gonna actually find some inverses. We've done some graphing here, but now we're gonna come up with some equations. So what do you think, guys? I'm gonna write y equals 3x minus 1. What would be kind of a common sense way of finding the inverse? Switch the x and y. That's how you find an inverse. You simply switch the x and y. Now, we got a thing in math about having y by itself, not x, especially in a linear equation. So I'm going to go ahead and add the 1 over and divide by 3. So this is actually the inverse. Correct notation, remember this is f of x to start with. So this should be f inverse. Have you seen that notation before? That's a -1. It is not an exponent. Please don't think it's an exponent. It's an inverse. F inverse is x plus 1 over 3. Okay? Miss Coleman, I want you to do something for me. I want you to plug 3 in the original function. What do you get when you plug 3 into the original function? 8. Now I want you to put 8 in the inverse. What happens?
You get 3.
Isn't that what we said would happen? If 3 gives us 8 in the original, then 8 is going to give us 3 in the inverse. Right? Easy. All right. B is a little harder equation here, but all the ideas are the same. The ideas are exactly the same. So well, I know how to start this one. I'll just switch my variables. Okay, this is not good. We need to be able to write that as an inverse function. So I need to have y over here. Okay, so what do you think? How am I going to do that? How am I going to eventually get y equals out of that mess?
Multiply both sides by y minus 2.
Multiply, get rid of fraction. So xy minus 2x equals 4y plus 1. Is that okay with everybody? Okay, I heard uh-huh. Now what?
Take out that.
Okay, now, I'm hearing a couple rumbles. I just want to make sure we're clear on something. Don't write this down. Could we subtract 1 and then divide by 4 and have y by itself? Yes. But why is that not a good thing?
There's y on
Because
both
there's
sides.
still a y on the
Other
other
side.
side. So, yes, your goal is to get y by itself, but it has to be the only y. So that is not how we're going to do it. What do you think? Oliver?
Divide everything by x, and then move the 4y over to the other side, and then 2x.
Now remember, if you divide everything by x, this is going to be over x. So it's not going to be able to be by itself. that would be backing up to where I was here, but you're on the right track. Sabrina?
Would you take the X out and put it in like this little side parentheses and?
Okay, well, we're all like getting close. You're kind of coming in on what we need to do. Dom?
I added the 2x to the other side and subtracted the 4y so you can factor out the y.
Ah, perfect. What is our objective? To have one y instead of two? So he said, let's put them on the same side of the equation. It doesn't matter which side, but let's put everything with a y on one side. Because at this point now, you can take out a y.
Yeah.
So now you only have one y. And we can divide. So a lot of you were on the let's divide mode, but we have to factor out the y first before we divide. So this is our inverse. Now, hold on, got a little bit of conversation we need to have here. This is really cool. Let's look at our original problem. Tell me about the vertical and horizontal asymptotes of the original problem.
Vertical asymptote is 4. Y equals 4.
Vertical asymptote, I'm talking about this problem right here. The vertical asymptote is x equals 2. Because vertical asymptotes are cannot be's, and x cannot be 2. The horizontal asymptote is y equals 4. Now let's jump down to our inverse. Where's the vertical asymptote in the inverse? 4. X equals 4. Where's the horizontal asymptote? Oh my gosh, is that what we expected to happen? Yes, because what do inverses do? Switch the ordered pairs. I can't believe you're not like just grinning from ear to ear. This is so cool. Sydney?
What happens if like the 4x over x or the 2x over x, like what happens if the, like let's say one of them is x squared?
Yeah. Well, they have to match.
Okay.
So if, let's just say for a moment, that was x squared. Then when I do my circle, they have to match. So I would have to put a 0 x squared in there.
Okay.
So then my asymptote would be 0 over 1 or 0. Okay? So no matter what, to find a horizontal asymptote, you are going to box in your highest power of the variable. If it's missing somewhere, you have to put it in a 0. Okay? All right. Here we go. All right, C. Okay, what's our job? I think still find the inverse, right? Yep, we're finding the inverse. So, x equals the square root of y minus 3, would you agree with that? Okay. What do you want to do with that?
Square by side.
Square both sides, so x squared equals y minus 3. And then y equals x squared plus 3. Alright, let's look at this a little bit because I think there's something a little off about this. I think everything you did was perfect, but I think we have to add something to it. What's this shape? This was the original. What shape is that? Okay, I see it's going like this, but it's been shifted 3 units to the right. So that is our original picture. Would everybody agree with that? All right. This is y equals x squared plus 3. Okay, so what is it?
3.
It is a parabola, shifted 3 units
Up.
up. So this was the point 3, 0. This is gonna be the point 0, 3, which makes perfectly good sense. But wait a minute. These ordered pairs are supposed to be those ordered pairs turned around, right? So something happened here that we need to address, because clearly there's more points here than there are up there. So what's going on, Sabrina?
Do you need just because it's just the positive ones?
Okay. So
I would
it
say
all
you
comes
would
back
put
to,
those little bars, but then the
Domain.
negative V.
it all comes back to domain. What is the domain of the original function? No, it's not all positive. X has to be greater than or equal to 3. So the domain of this guy is 3 to infinity. Would you agree with me? What's the range of this guy?
0 to
0 to infinity. Whoops. Now, groupies, when I do my inverse, what has to happen to the domain and range? They have to flip-flop, because those x's become these y's, and vice versa. So the domain of this function has to be 0 to infinity. And then the range will be 3 to infinity. Now, that part I don't have any problem with. I think the range matches up. But in terms of the domain, I have to have positive x's. So this part of the picture doesn't get to be drawn. Which means when I write my answer, I have to make a little note over here to the side that says x is from 0 to infinity. In other words, you have to stipulate your domain. Otherwise, it won't work out right. Austin, you see what I'm saying? You have like a glazed look in your eye. Still thinking about the french fries from lunch? We gotta watch that, guys. Domain is important. All right, D, here we go.
Are we gonna have to check that for all the problems, or is it just a specific?
Well, I would say you're gonna have to check it anytime the domain of your original function is restricted.
Okay.
In the range of your original function. You need to consider that. Because any restriction on the original domain and range is gonna restrict the domain and range of the inverse. So really, I suppose, Oliver, it's more important to look at the range of the original, because that will
That
become
becomes
the
the domain.
domain of the inverse. So, that brings us to the next one. We're gonna do one more problem. Come on, let's get her done. So P of x, or obviously y, equals x cubed minus 5. What is this shape? It's my cubing function, wiggling through the origin. But what have I done to it?
5 units down.
5 down, so now it is wiggling down here, right? Now, to Oliver's point, are there any restrictions on the domain or the range of the original?
No.
What does that imply? There will be no restrictions on the domain or range of the inverse, right? All real numbers all the way around. All right, so what's that inverse gonna look like? Well, here's my original, so x equals y cubed minus 5. X plus 5 equals y cubed. You with me? Y equals the cube root of x plus 5. Now, cube roots are not a BFF. Square roots are. This has no domain problems. Can you take the cube root of a negative number?
Yes.
Yep, no imaginaries in cube root land. So this is your inverse. Any idea what it'll look like?
Rotated.
It'll be a sideways version of this, but instead of going through the point 0, -5, it will go through the point -5, 0, right? It's gonna squiggle through like that. A reflection across the idea. Woo! Lots of good stuff. What an exciting day in math. Be sure to share with your parents what a fun day we have.
No.
Learning